Welcome students. In this video I will be showing you an Arduino project. This Arduino project is an LED chaser with sound buzzer. This project will guide you in creating an LED chaser effect using an Arduino Uno R3 board. We will be using also a 74HC595 chip register and some 8 LEDs, 8 resistors, a push button, a breadboard. I have 2 breadboards to make it easy. You might only need one. I need a decent size, a medium size, and a buzzer. The buzzer will sound each time the LED sequence completes. So what is an LED buzzer? What is an LED chaser with a buzzer? So as you press the so it's a cycle LED chaser. That means that it will when you upload your project to the Arduino board for the first time, the first LED will light up, and once you start pushing your push button, the shift register will start shifting the LED light to the next LED to the side, and once it finish all the cycle for all the LEDs. It will buzz a sound, and the cycle will begin again from the beginning LED. So it's a very nice project to work with. So these are the components you're gonna need. You're gonna need an Arduino Uno R3 board. You're gonna need a 74HC595 chip register. You're gonna need 8 LEDs, 8 resistors, 220 ohms, 1 push button, 1 buzzer, 1 breadboard, 1 jumper wire. You might also need one 10K ohm resistor for the push button. A 10K ohm for the push button. Okay. So here's the circuit setup. We're going to connect the 74HC595 chip register. So pin 14 is the DS pin. We're gonna connect it to Arduino pin 11. Then we're gonna connect pin 12, which is the latch pin. We're gonna connect it to Arduino pin 10. Then we're gonna connect the pin 11 from the chip register which is the clock pin, to Arduino pin 9. Then we're gonna connect pin 8, which is the ground of the chip register, to the ground of the Arduino, from the Arduino we're going to have a path to the breadboard for common ground. And then pin 16 of the chip register, which is BCC, we're gonna connect it to the 5 volts common 5 volts from the Arduino. And then we're going to connect it to 5 volts coming out of the Arduino as well, which is the master. In the pin 10 is the master reset, and pin 13 is the output enable. We're going to connect it to ground as well, and the common ground is from the Arduino as well. I'll show you this a little bit when I go over on my second video, when I show you the actual circuit working. Now let's connect the LEDs to the shift register. So we're going to connect the anode of each LED to the output Q0 to Q7 of the chip register. So you might want to look at find a schematic for the 74HC595 chip register online. You should be able to find one. Now you connect the to the 220 ohm resistors from the negative cathode to the ground. Now the button, you connect one side to 5 volts and the other side to pin 7 with a pull down resistor, take 10k ohm to ground. I'll show you how it works on my end. And now the buzzer is the sound. So you connect the positive Arduino to pin A, the positive leg to the Arduino pin A, and the negative to ground. Now let's go over the code. So those that we designated, the pins coming out of the shift register, the pin 11, the 10, the 9, those are we're going to code them. So those are here. The data pin is 11, DS data source. The latch pin is 10 on the code. The clock pin, the 9, as we assign it here at the beginning. The button is 7, and the A is the buzzer, as we said here. And we're going to create a variable LED, which is going to be a byte. Byte is going to be 8 bits. And we're going to create a button, a boolean button press, and we're going to initialize it as false. Now we're going to create the setup function. So the latch pin is going to be an output, the clock pin is going to be an output, the data pin is going to be an output, button pin output, buzzer output. Button pin input, buzzer pin output. We're going to initialize the LED pattern as having 1, the value 1. And then we're gonna update the shift register. We're gonna call the update shift register function, which is this one here. So what it does, it writes on the latch pin as low, and then it chips out the LED byte. It chips out an LED byte. It chips out 1 byte, because at the beginning it was the byte was 0. So then when you initialize it, it is 1. Is 1. So in other words, it will light up 1 LED only. That's what it does. and then the latch becomes high. Now we go through the loop. Now when we press the button, if the button was pressed, that means that we say button is pressed is true. We shift the register by saying we shift the LEDs or the register. If the button was 0, then we shift it to 1. That means we're at the end. If this happens when we're at the end, and we put a buzz and we make the sound, this is when we're right at the very end of the cycle. I have here 200 milliseconds for the buzz, but I put 800 on the actual code, so it sounds more, so you can actually hear when I record the sound on part 2 of my videos. So if if the LED is not zero, that means that we're in the middle of the cycle, or somewhere in the middle, somewhere there, not at the end. We're gonna shift by 1. We're gonna shift the LED pattern by 1, and then we're gonna update the shift register, the function, with the update shift register function. And the same we do it. We shift out the byte. First we shift it here, and then we shift it out. And this is needed, and else if digital red, if button is low, then we make it false. Button press equals false. So we're switching, so that this works. This if statement works each time. So how does it work? How does the whole code works? The 74HC595 shift register controls the LEDs, allowing you to use only 3 Arduino pins to manage all the LEDs. The button when pressed will shift the LED pattern by 1 position. If the pattern resets, the buzzer will sound to indicate the completion of a cycle. The tone function is used to generate a sound on the buzzer. So what is the latch for? Why do we need it? The shift register is a versatile component used to extend the number of output pins available in a microcontroller like the Arduino we have. One of the critical features of this shift register is the latch pin, which plays a vital role in controlling the outputs. So what is the latch? What is the latch for? It's referred to as the storage register clock pin, STCP, storage register clock pin. It is responsible for controlling when the data has been shifted into the register is transferred to the output pins. So first, so the data is shifted, but then you want to know, so it basically controls when you're going to actually output the data into the LEDs, basically. So data is shifted, but you don't know when it's going to be outputted to the LEDs, but the latch does. The latch is used for that. So data is initially shifted into the register using the data pin and the clock pin SHCP. Each clock pulse shifts the data 1 bit further along the internal register. So we store the data. As the data is shifted in, it is temporarily stored in the internal shift register. However, this data is not yet visible on the output pins. Now when we transfer the data, the latch pin determines when the data from the internal shift register is transferred to the output pins. This transfer occurs when the latch pin is toggled. When the latch pin is set low, the data remains stored within the internal register, and the current state of the output pins does not change. When the latch pin is set high, the data in the internal register is transferred to the output pins, updating their states according to the shift data. So if you look at the code here, first it is low. That means that here the data is still inside the register. So here shifting out, here shifting. But once it's set to high here, then is when the LEDs start lighting up. So why is the latch important? Control updates. By using the latch, you can control when the output pins are updated, allowing for precise timing and avoiding glitches during the data shifting. If it does consistent output, the mechanism ensures the outputs change simultaneously, providing a consistent and stable output state. It is efficient because it allows to perform multiple data shifts without affecting the output, only updating when necessary. In the context of the Arduino LED Chaser project, the latch pin enables smooth transitions between LED patterns, ensuring the LED lights up in a precise sequence as intended by the code. This setup provides an engaging and interactive experience demonstrating the use of chip registers, LEDs, and sound in Arduino projects. I hope you liked my video, and on my next video, part 2, we're going to load the I'm gonna load it, and I'm going to show you what the Arduino LED chaser with sound buzzer looks like and sounds like. So thank you for watching. Please subscribe, and let's look at part 2 for the fun part, for the more fun part. Okay, thank you for watching. Please subscribe.